Now we're into the second section of Trig, which deals with the right triangle trigonometry. And this is generally the thing that you probably know as SOHCAHTOA, right? So a right triangle has a right angle in it, obviously, right? And then the other two angles both have to be less than 90, meaning they're acute angles. So a right triangle is going to have two acute angles and a right angle, right? So in this case, theta and that angle there are your two acute angles. And the side that's opposite the right angle, you know as that's opposite, right? So that's going to be called the hypotenuse, and it's the longest side of the triangle, so that's important to keep in mind. The other sides of the triangle are the legs of the triangle. These sides can also be described by their position relative to the acute angle theta. So one side is going to be, we call that opposite, and one side is next to, which we call adjacent. Now you might say, hey, well, that side there is also adjacent theta, but no, that's the longest side. The longest side is the hypotenuse, right? Opposite the right angle is always the hypotenuse. So when we say adjacent, we're talking about the leg adjacent the angle. So that leg there is the adjacent leg. And then in any right triangle, the sum of the squares of the lengths of the blank is equal to the square of the length of the hypotenuse. Well, I mean, that's got to be the only possible thing there has got to be legs, right? The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. That's just known as the Pythagorean theorem. So the trigonometric ratios. So you have the angle theta, you have the leg that's opposite theta, you have the leg that's adjacent theta, and you have the hypotenuse, right, which is opposite the right angle, right? And in this case, there's your right angle. So based on the triangle, complete the following. Well, this is where SOHCAHTOA comes into play, right? So if you remember SOHCAHTOA, the sine of the angle was always the opposite over the hypotenuse, right? That's the SO part. The cosine was the adjacent over the hypotenuse. That's the CA part. And then the tangent of the angle was the opposite over the adjacent. So that was the TOA part, right? So there's your SO, CA, TOA, right? And then the other ones, the cosecant, the secant, and the cotangent, these end up just being the reciprocals of the sine, cosine, and tangent respectively. So the cosecant is the opposite of the sine, so that's going to be hypotenuse over opposite. The secant is the reciprocal of the cosine, so that's going to be the hypotenuse over the adjacent, and the cotangent is the reciprocal of the tangent, so that's going to be the adjacent over the opposite. So I sometimes call this choshakao, right? So then the whole phrase is SOHCAHTOA choshakao, because this is CHO SHACAO. So SOHCAHTOA choshakao. But it's easier just to probably remember SOHCAHTOA and then realize that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and then the cotangent is the reciprocal of the tangent. One other thing that you probably want to just realize at this point is sine and cosine, since they're always legs over hypotenuses, leg over hypotenuse, they're always going to be less than 1, right? And then since cosecant and secant are the reciprocals of those are always going to be greater than 1, right? Because if these are less than 1, the reciprocals are going to be greater than 1. And then tangent, it could be greater than 1 or less than 1, right? It depends on which leg is greater. Sometimes the opposite leg is greater, sometimes the adjacent leg is greater. So tangent could be greater than 1 or less than 1, and cotangent can also be greater than 1 or less than 1. But sine and cosine always have to be less than 1. So if we're given a triangle, right, here's your angle theta, there's your opposite, which is 7, your adjacent, which is 6, and your hypotenuse here, which we don't know, but we can find it using the Pythagorean theorem, right? So the hypotenuse is just going to be 7 squared plus 6 squared equals the hypotenuse squared, right? That's a squared plus b squared equals c squared. So it's 49 plus 36 equals c squared. So it's going to be 85 equals c squared. And then you take the square root, so we get the square root of 85 equals c, right? So we might call this arrow math, right? I'm going, instead of working down, I'm working across. So I'm just saying this means this, means this, means this. So c is then the square root of 85. So now that I have all three sides, I can just write the ratios, right? So the sine was the opposite over the hypotenuse. So here's the opposite, there's the hypotenuse. So it's going to be 7 over the square root of 85. The cosine of that angle was the adjacent over the hypotenuse. So there's your adjacent, there's your hypotenuse. So that's going to be 6 over the square root of 85. And then the tangent is going to be the opposite over the adjacent, which is going to be 7 over 6. And then they have this lined up nicely where everything, the things underneath are reciprocals of the things above, right? So the cosecant is the reciprocal of the sine. So that would be the square root of 85 over 7. Secant is the reciprocal of the cosine. So that's going to be the square root of 85 over 6. And then the cotangent is reciprocal of the tangent. So that's going to be 6 over 7. And there's nothing that we're not solving for the angle there. We're just stating what the 6 trig ratios of that angle theta are. We don't know what theta is. We just know those are the trig ratios of that angle. So what we're going to do here now is give ourselves a little bit of room. And they're telling us to sketch a right triangle that has theta as one of its acute angles. And then we're going to let the cosine of theta equal 2/5. So what that means is, let's insert a picture here of a right triangle. So if that's our right triangle, and we're going to have an angle theta, so let's just call this angle here maybe theta, and here's your right angle, of course, right? So now they want us to let the cosine of theta be 2/5. So if the cosine of theta is 2/5, remember cosine was adjacent over hypotenuse, so we can think of this 2 as being the adjacent and this 5 as being the hypotenuse. So we can then set this triangle up to go along with that, right? So if this is theta, there's your adjacent. So the adjacent is going to be 2, and here's your hypotenuse. That's going to be 5. That was supposed to be a little arrow there to the adjacent. There it is. So now we can find this missing leg by using Pythagorean theorem again. So in this case, it's going to be 2 squared plus the other leg squared equals 5 squared. So we're going to get 4 plus b squared equals 25. So b squared equals 21. So b is the square root of 21. So now this is going to be the square root of 21. And now it's easy. Find the values of the other 5 trig ratios, right? So if we know cosine is 2/5, the easy one to get from that is just that the secant of theta is going to be the reciprocal. So that's 5 over 2. And now the sine of theta is going to be the opposite, square root of 21 over the hypotenuse, which is square root of 21 over 5. And then the cosecant of theta is going to be the reciprocal of that. So it's going to be 5 over the square root of 21. And then the tangent is going to be the opposite over the adjacent, so the square root of 21 over 2. And then the cotangent is going to be the reciprocal of that. So it's going to be 2 over the square root of 21. So there's your other 5 trig ratios of theta. Right? And again, the cosine had to be less than 1, and the sine is also less than 1, right? Because the square root of 21 is less than 5, so it's like 4 point something over 5, so that's less than 1. So it works out.